In this video, we're going to take a histogram and turn it into a density curve, or at least show the relationship between the two. So let's create a whole new distribution, and let's just say the variable if this is we'll say the age of viewers watching the Knicks game. All right, and we're just going to base this list off of, let's say it's a group of people watching it at Buffalo Wild Wings, one of my favorite places to eat. So we're just going to put BWW in their parentheses, and we're going to look at a list of those people. And let's just say it's a slow day. The Knicks are doing horrible. And in our group, in that one restaurant, we have a kid who is 17. We have a person who is 23, another person who's 28. Let's say we have a 33-year-old, 36, 38. Say we have a 45-year-old, 49. And let's say our last person in this case is 51 years old. All right, I'm just making these numbers up. So in our restaurant, we only have 1, 2, 3, 4, 5, 6, 7, 8. We have 9 people in the whole restaurant. So we're going to say n is equal to 9. If I wanted to make a very, very basic histogram based on this distribution, okay, my range, I'm going from 17 to 51. All right, so roughly, a range of about 30. Let's just say for the sake of this, I'm going to make classes from 0, we'll say 0 down here, up to age 60. Okay, and I go, so this will be 10, this will be 20, this will be 30, this will be 40, this will be 50, and let's scoot that guy up a little bit to make it look a little nicer. We'll say that is 60. Okay, and I'll put all the different labels in here. So this is 0 to 10, 10 to 20, 10 to 30, 30 to 40, 40 to 50, and then this bar would be 50 to 60. Okay, let me make a quick little frequency axis. So this will be the number, how many times I see different ages in each class. And I think as I go in the tens, the most I have is 3. So I'm just going to make this a count of 1, a count of 2, and a count of 3. All right. So 0 to 10, there's nobody. 1 to 20, I have one person. All right. 20 to 30, we have 2. All right. 30 to 40, I have 3. And forgive me, these bars are not even. I'm not the best drawer. 40 to 50, we have 2. And then 50 to 60, we have 1. Okay, I think we can all agree this is a pretty normal distribution. It's based off of the fact that there's only 9 people here. So if I asked you what percentage of this distribution is below the age of, we'll say, 45. Okay, because my sample size is so low, I mean, it's very simple to just count off 1, 2, 3, 4, 5, 6, 6 out of 9, or roughly 67%. And I can answer that question fairly easily, right? 67% of the people watching this game at Buffalo Wild Wings is 67%. 67% are younger than 45. But let's say there were 900 people, or I wanted to look at 12 different branches of Buffalo Wild Wings over a span of 17 Knicks games, and now my sample size has increased from 9 to 900. Okay, it'd be very tedious to make a histogram with all these bars and counting up all these numbers. It'd be a headache, right? If I had to look at a sample size of 900. Okay, so what do? We can make an estimate of what that histogram would look like based on that distribution's density curve. Okay, and that's what a density curve is. It's an estimate. Okay, and I'm just going to write down here density curve is, we'll just say it's a way to estimate the histogram of the population. For example, given this histogram, my density curve might look something like this, where I come down and I just draw it through. Okay, now technically a density curve is not supposed to cross that axis, but once again, forgive my art here, and I'm actually going to redraw that because the first time we're seeing this, I want this concept to really sink in. All right, so in theory, once again, it's supposed to be symmetric. And notice how the second time I draw this, I'm going to try my best not to cross over that axis. And I put little arrows because technically this curve goes on forever, right? It's continuous. It goes from left to right, boom, all the way up to my peak, and comes all the way over. All right. Now, a couple things about this density curve. Okay, it represents 100% of the population. Okay, it's a continuous histogram. If I was looking at 900 people, all right, or the ages of 900, it would, all 900 of those ages would be captured by this density curve. Okay. Likewise, if I were to ask you in this histogram, the one that I'm highlighting right now, is it safe to say that 100% of my sample is in this histogram? Okay, now my sample is only 9 people, but yes, I would say 9 out of 9 is captured by this histogram, right? I have 1 here, 2 in here, I'm up to 3, 3 in here, I'm up to 6, 2 in here, I'm up to 8, 1 here, I'm up to 9. Okay, so just like 100% of my sample of 9 fits underneath of this, and it fits underneath in this histogram, I'd say 100% of my 900 are going to fall underneath of that curve. Okay, now we'll talk a little bit more about how to draw this curve and how to use this curve, but for right now, I just want us to concentrate on the fact that it's an estimate of what the histogram would be of the entire population.